Hello everybody, today I want to teach you about text networks. In order to learn about text networks, we first have to answer a much more basic question, which is simply, what is a network? Well, in its most basic form, a network is a group of nodes and the edges or connections between them. Now, maybe you've seen something like this before. This is a simple social network diagram. And here we could think of the little circles or nodes as individuals, and the edges or lines between them as describing some type of relationship. Maybe these are friends. And maybe all of the people in this kind of little red click named each other as friends. All the people in the green click did as well, and all the people in the blue click did as well. Now, this is a very common way to think about social networks. But we could also be talking about computer networks or really any kind of relationship between any kind of thing. And that's a kind of fundamental principle of graph-based thinking. So we take that logic in text networks and we can do two things. We can say either we can draw edges between two people based on similarities in the type of words they use when they write or talk or speak, or we can treat the words as the nodes as the network and draw edges between the words when lots of people use the same groups of words. That's the key intuition behind text networks. So at root, it can do something very similar to topic modeling, looking for patterns and groupings of words that cohere up to things you might call topics, with some additional advantages I'll describe. But it can also be used to cluster the authors of the documents themselves or group them according to similarities with some additional advantages as well. So let's take a look at an example. In this example, we're looking at 6 people and how they're talking about coronavirus. And these people are all kind of talking about coronavirus in different ways. Some people are talking about testing and the need to get testing back in order before the economy can get started back up. And others are kind of pushing another narrative which says that the Chinese government is to blame for the COVID-19 outbreak and that it was started in a lab in Wuhan, China, right? Common conspiracy theory. So what a TextNet can do is first, if you look on the left-hand side, you'll see the full text of these statements. And you'll see that in bold, I've bolded out the nouns here and the noun compounds, just meaning noun phrases. And so what you see is we can represent these texts in a graph format in that first panel on the upper right-hand side of this diagram. And what you're seeing there is sometimes we call a two-mode network, meaning that there's two things being described at once. First, we have people. They're in boxes. There's 5 of them. And then we have the words, or nouns in this case, that people are using. And those are the little orange ellipses in this diagram. And so every box has a connection to a noun that is used by the person in that box. And we thus can kind of describe patterns in the way that people jointly use words. So if you follow me down to the kind of center left of this diagram, you'll see what you might call an author network, or you might also call it the projection of the author network, to use some network language. And basically what we're doing in this graph is we're connecting people who use similar words. And we're connecting people who use similar common words with weaker edges and people who use similar unusual words with stronger edges. I'm not going to get too much into the details of how we do that. It has to do with using something we learned about in an earlier lecture on basic text analysis called the term frequency, inverse document frequency. Basically, we create these edges with weights that are the sum of the overlapping TF-IDF of the terms that any two people use in a corpus. If you want to learn more about the technical details about that, I've got an article I wrote linked at the bottom of the slide here, and you should also check out another article by Rule et al. So the author network might be useful to you if your goal is to cluster people according to similarities in the way they talk. Now, on the other hand, if you wanted to do something closer to topic modeling and you wanted to cluster words into latent themes or topics, then you might want to follow with a kind of word-based projection of the network, or what you might call a word network. On the lower right-hand side, you'll see here that these groups of people have kind of cohered into two ways of talking about coronavirus. Either it's a threat that requires extensive testing to overcome in order to avoid economic harm, or the economic harm resulted from an intentional strategy by the Chinese government to create coronavirus in the lab. This is a very toy example. Obviously, when we do this with hundreds of authors or hundreds of thousands of documents, the picture is a lot less nuanced. And of course, these networks get much, much bigger. But hopefully this slide gives you a little intuition about how we go through the process of building a text network. Let's look at some examples of applications of text networks to try to give you some appreciation for where the technique can go. This is from a paper that I love by Elise Rule et al., which takes the State of the Union addresses. These are the yearly addresses that the US president gives every year, and it creates a word-based projection of every word that co-occurs across different speeches. And so what you're seeing here is the representation of that word network. Now, instead of my previous example where there's only 5 words, there are thousands of words in this example. And they've been laid out in a network space using an algorithm. You don't make anything of the XY coordinates here. Essentially, the words are placed nearby words that they are similar to in terms of their connections to another words using something called community detection. This is something called the Louvain community detection method. But basically what you can see is that the network structure between words pulls out some very familiar concepts if you're familiar with US government, things like statecraft, the economy, international relations, something very similar to the kind of topic models that we looked at earlier. But a really nice advantage of the text network is we get a single visualization to see the entire corpus in one picture. Not only that, we get to see how dense the clusters of words are that cohere into topics. Though topic modeling gave us kind of a mixed membership model that allowed us to account for words that are kind of in between clusters, we couldn't really see them or see how they're guiding the assignment of individual words into clusters. And so here you can see not only which clusters are most cohesive, but also which words kind of bridge multiple clusters. And very often we want to know about those kind of in-between spaces and theories in social science, especially theories informed by social network theory, of which there are very, very many. So that's kind of a neat way to think about a text network with a kind of interesting social science application. We can also do these projections over time. So here, the community groups identified by the so-called community detection algorithm, which is coloring those nodes in the previous slide by the similarities in how they're connected to other words. Now we're just grouping those by time increments into this neat kind of Sankey diagram to look at how topics emerge and kind of come and go out of other topics in this interesting diagram from that same paper. So if you'd like to try out text networks, I've developed an R package called TextNets. To install it, you'll need the DevTools package, and you can install it using the install.github function. But this function basically does a few things for you. First, it does text preprocessing, and if you need to learn what text preprocessing is, go back and check out my video on basic text analysis. Second, it creates the text network, and that is basically taking large unstructured text counts and projecting them into an adjacency matrix, which is very similar to a document term matrix with some subtle differences. Third, it has a suite of methods and functions for visualizing text networks. And finally, it has tools for interpreting or detecting themes within networks as well. So the TextNets package comes with a data set that is the State of the Union data, the same data that we were just looking at in the Rule et al. Paper. So you can load the package and then load the data set using the data function. And then if you want to browse that, you could use the view function to take a look at the data. But basically, each line of the data has a president, a year, and then the full text of the speech. Now, one downside of TextNets is that we use a technique called part of speech tagging in order to pull out the nouns because the bet here is that most of the substance of a given discourse probably lives in nouns. TextNets allows you to turn on and off that feature, so you can limit yourself to nouns, you could limit yourself to verbs, you could limit yourself to adverbs and plot different networks if you were trying to, say, distill themes from maybe opinion-style networks. But either way, one downside of this technique is that it requires a lengthy algorithm to pass through every single sentence in the text. So this could take anywhere from 5 to 6 minutes on a fairly well-powered laptop, but if you're on a slower computer, it could take 20 minutes or maybe even 30 minutes if you've got a really large data set. So just keep that in mind. And for the example we're working with, we're just going to look at the first speech by each president to speed up processing time a little bit and allow you to play around a little bit with TextNets. So the first core function in the package is called PrepText. PrepText reads in a data frame, and within that data frame, we need to give the function a grouping variable. That's the author. In this case, that variable is called president. We need to tell it where the text is. In this case, that variable is called so_text. We need to tell it whether we want to do a author-based projection or a word-based projection. That's the node_type argument. If you want to do an author-based projection, you should write groups. If you want to do a word-based projection, you should do words. Next, it gives us the option to tokenize by words or other tokens. And then this next argument, POS, stands for part of speech, allows you to specify which parts of speech you want to keep in the analysis. You can remove stop words, and you can choose whether or not to allow the part of speech tagger to pull out proper nouns, things like the United States of America, which would otherwise become United States of America. Okay, so the kind of core function within the package is called CreateTextNet. That reads in a prep data frame and produces an iGraph object. iGraph is a library in R for network analysis. And once you've got the data as a network, then you can begin doing anything you want with it, visualizing it, analyzing it, interpreting it, running various types of community detection on the network to pull out groups of either authors or groups of words. So first, let's try out the TextNet with nouns, and let's try an author-based projection. So here the goal is to see if we can group presidents according to similarities in the types of nouns that they are using. So the function we use to produce a visualization is called VizTextNet. That reads in a prepped and network-shaped version of the dataset that you created in the first two steps. Next, it includes an alpha parameter. This alpha parameter is really important. This determines how many edges or connections within the visualization are going to be displayed using something called a network backbone technique. If you choose lower values, fewer nodes and edges will be displayed. And if you choose very large values, many nodes and edges will be displayed. We've, in our experience, found that about 0.2 is a good cutoff, so that's the default value. But if you're seeing a network hairball, meaning lots of just lines between a lot of circles and you can't make heads or tails of it, try dropping the alpha parameter. Next, there's an argument called label_degree_cut. That specifies the threshold at which you want the visualization function to label each node with the name of either the author of the document or the word. And if you have a very large network, you may consider dropping that to a very high, or increasing that to a high threshold to prevent every single thing from being labeled. Okay, so here's how a TextNet on nouns with our American presidents looks like. And if you can follow this on the left here, you'll see very recent presidents all grouped near each other: Obama, George Bush, Bill Clinton, and so on. And on the right, you'll see, the first few presidents: Washington, Jefferson, and so on. And you can kind of follow time along this graph here. Remember that X, Y coordinates don't mean anything. Nodes are simply placed nearby each other by an algorithm according to their similarities to other nearby nodes. You can specify different layouts as well if you want within TextNets. So what's cool here is we see that TextNets is able to pick up that presidents at different periods of time are talking about different substantive topics. So George Washington is not talking about the war on drugs, and Bill Clinton is not talking about the British coming, right? So remember, we're only looking at nouns here, so it makes sense that mostly we're picking up time period. We can also create really neat interactive visualizations in TextNets using some D3.js graphics from the Network D3 package. So if you run this code, your R viewer will open up an interactive network plot. If you mouse over the nodes, it will reveal the node labels, and you can drag the nodes to reposition the network and move it around and interpret it and play with it a little bit more. What if we want to do a word-based projection instead of an author-based projection? Okay, well, we didn't have too many presidents, right? A couple dozen, but we have thousands and thousands of words. So the word-based projection here is a lot bigger. Basically, if you follow along one of my annotated code tutorials online, you'll see instructions about how to simply flip the node type argument within the PrepText function in order to create a word-based projection instead of an author-based projection. So here you're seeing what we saw earlier. Each kind of colored group is a group of words that cohere into a latent topic. And again, we can see not only how cohesive each topic is, but how they relate to each other and what types of words are kind of in between topics, all within one really efficient visualization. Another nice thing about TextNets compared to topic modeling is that the number of topics is kind of chosen by default for you using the Louvain community detection method. As with topic modeling, however, and some of those goodness of fit measures that I talked about for topic modeling in a previous video, these things are not set in stone. This is the algorithm's best guess. So if you're seeing some kind of shady groupings of the words, it may well be that the algorithm has made a mistake. And as before, in other kinds of automated text analysis, there's just no substitute for human validation of a text network. So now that we've visualized them, we've seen how to build them and prep them and kind of put them together, how do we make sense of them? Well, TextNets also offers a few tools for doing that. The first is you can pull out those communities, the different colors in the graph, and either browse them and see who's in which community a little more closely, or you can pull out the top words associated with each grouping. So we can go through and see, well, what precisely were the words that Clinton and Obama were using that were so different than the words that Jefferson and Washington were using. And of course, we need to specify how many of those top words we're going to look at. Here we're looking at 10. Another really neat feature of a text network is we're able to exploit the kind of full artillery of techniques and theories for social networks. So if you're familiar with some basic social network theory, you'll know that a lot of theories in social networks emphasize how people in between clusters of networks often serve kind of key roles in spreading ideas or often receive disproportionately large social advantages by virtue of being able to connect different groups of people. So with TextNets, you can both look at who is in between kind of discursive communities, if you will, who's the kind of key broker connecting the flow of ideas across communities, for example. Or in the case of words, you can try to figure out which words are really central to the discourse and linking different themes together, and how do different actors use those. By comparing the author projection to the word projection, you can do some really fun analyses of how kind of structural networks between people overlay onto cultural networks between ideas. If you want to read more about that, I have a paper in the Proceedings of the National Academy of Sciences in 2016 that develops a theory of that as well. So TextNets is relatively new. The idea to create text networks has been around for some time, but we're really starting to push things in really exciting new directions. So for example, social networks can not only have edges between people, but those edges can have a valence. People can have a positive relationship to each other or a negative relationship to each other. And once we use that type of identification of network structure, we can build much grander theories of human relationships. such as balance theory, which accounts for social structure as patterns in positive and negative relationships between people. Could be legislatures, elected officials, could be students in a school. And the way we're starting to do that with a new function in development in the TextNets package that you can read about on our GitHub page is to integrate sentiment analysis with sentence parsing in order to connect people who talk about the same things in similar ways, say people who have similar attitudes towards immigrants or similar attitudes towards security issues, and then also connect words to each other by how they're used in terms of their sentiment by multiple authors. So again, it's an exciting new way to move us beyond sort of like measuring a topic and towards measuring something closer to an opinion. Thanks for joining me.